And for new faces, my name is Amira Al-Bidawi and I work at Vattenfall as a business development manager in our open innovation platform called Greenfield. Okay, and I'm super curious, we have some things over there, but we'll keep that as a cliffhanger.
Okay.
And I would like to first ask you all to tell us a little bit about yourself and how you're using 3D printing in your work today. So we can start with you.
My name is Calin Brandabur. I'm the Vice President of Engineering at LTHD Corporation and CEO and founder of CIMET 3D. We are building the engineering aspect of different additive manufacturing technologies like 3D printers for thermoplastic, metals, and lately biomass.
Yeah, Stefan Reinebrandt, Production Technology Manager in the IMO, the insert plant. We work since 2008 doing a lot of spare parts, but also picking nozzles and so on that is not possible to do in other way in 3D printing today, actually.
Yeah, my name is Dirk Voelkel. I'm Chief Technology Officer for Innovation and Analytics at GE Healthcare, and specifically in life sciences. And we have a big plant here in Uppsala with 1,200 people, or actually a bit more, 1,300 people. But most importantly, we actually invested a few years back into an additive center here for Europe. And so we have a center here with many capabilities. And we're at the stage where we actually have additive moving into production. So it's actually, we use it for manufacturing for certain pieces and as real products. And that's a massive step, and I think we do that, and that's been a great transformation for us.
Fantastic. So in my industry, I've seen 3D printing being used for prototyping, for creating models for hydro power plants and dams, and later in order to be built. But what other types of 3D printing are there? And could you tell us a little bit about that with some examples?
Well, I'd like to challenge the audience, just name one industry where you can't use a 3D printer. Because you can use it in pretty much anywhere. For example, we are using it in automotive industry. We are building spare car parts or building the molds which are being used on assembly lines for assembling the dashboard or whatever. We are using them in aerospace industry, where we can actually build engines, like real working engines, or molds for specific parts in our aerospace industry. And lately we are using them in medicine, where right now we are, by the way, we are from Romania, from western part of Romania, and we've started working with biomass, something that I've never imagined as a startup of 3 years old, that we've actually going to get to that to this stage. Biomass is basically human organs. We're not talking about functional human organs at this stage, because this is very early in the research cycle. But we've already made quite a few progresses, and we already raised a couple of million euros just to start making two important projects. One of them is the pancreatic isles, which is basically aiming to build the part of the pancreas which is secreting insulin. If we are managed to prove that a 3D printed pancreatic isle is secreting insulin, this is a game changer. Just because we are tackling the donor industry, nobody has to wait for donating pancreas, and obviously we are solving two important issues, diabetes and pancreatic cancer. So 3D printing is basically changing our future, changing our present, and will change our future.
Thank you.
Yeah, and we started with plastic printing, and that was more like that is a melt printing. And that is you get a part directly from the table, more or less. But also we use powder bed fusion, and that is something that you can use a lot of metal alloys and have special for powder. It's a powder bed and using laser or electro beams. So that's the different types but that's the one that we really focus on. We can do a wide range of metals today, and the thing is that you can manufacturing parts that's impossible to do. You cannot do it with metal cutting, and you have a much stronger and also often very light product. So you can for aerospace it's really good.
We actually, just to add to that, I just saw, and I'm working in healthcare, but GE Aviation uses 3D printing. It's actually, that's where it started in our company. And they just got FAA approval for a holder for an engine, which is additive manufactured, so 3D printed metal piece. So it just got approved, so that shows you, the step from, yes, we used it for prototyping, and yes, it helps engineers a lot to cycle much faster through designs when you needed to work like 12 hours to get something manufactured or maybe molded. Now you can, within 1 week, get it produced and you get much quicker feedback. So actually it increases also the speed in development. But the step from actually having then the final product already means that you actually not just have a prototype, but you have something that's a final product. Transfer into manufacturing is easier, lots of things. But at the same time, it's a huge challenge. At least in the medical industry, you need to make sure that the raw materials are qualified, high quality. The whole supply chain needs to be clear, quality control of the printed pieces. So there are many steps from just using it for prototypes to actually real product. But once you overcome that, and we're on the process of overcoming that and learning about it, that's a massive change for, as you say, name an area where you can't use it. And I think there's so many areas where we start to be able to use it. So, and we have concrete products where we use it today.
Yeah. And I saw some of the products back in the exhibition area as well. And you've been so kind to bring some of these things here as well. Would you like to show us any of these and perhaps allow the audience to...
Yeah, you can walk up later and to touch it. So this is one piece that we have for a filtration system. And then this is subtractive manufacturing. So this is traditionally manufactured. And the first thing that we do, we look at pieces where this is quite heavy and it's very expensive for us. And this is a 3D printed version of the same thing in the next iteration. And you can see, product quality wise, we're very close, but it's a lot lighter than this one here. And has a lot more features that we can actually now work off and to optimize it further. But this is one example. When you look at surface qualities and all of that, it's just amazing what happened over the last few years. So this is one example, and I don't want to hand it around, it might be falling on someone's foot, but it's quite heavy actually.
It really is.
But maybe polymer parts here, this is a part that had we had several parts that were separate parts, and this is just it's something that we put into an instrument. It's called BioCore instrument as a transport mechanism. So you put it in, and before we had several parts that were manufactured separately, and now this is one piece that we removed before we use it, but it fulfills all the function and we can print it. And one other thing that I realized talking to our guys is I always thought it was quite expensive to print pieces, but costs are coming down dramatically. And so now we're actually at a point where it's economically feasible, not only feasible, but beneficial to actually print things.
We also an example that we have a face mill. The cutter body of it today is pretty heavy, and we did 3D printing. It's 80% lighter, and we have a productivity that's come from 50 to 200%.
Yeah.
Just because you can stress it much more when you mill. So that's really interesting.
That's really impressive because it has massive sustainability effects. Would you like to elaborate a bit about that, the environmental effects, health effects, and also resource-wise?
Yeah, first of all, subtractive manufacturing, you take all the parts away that you don't use, and that's waste. You can recycle it some way, but basically it's lost. Whereas in additive, you add pieces, and in theory, you only use the pieces that you use later. There's some loss, but we can recycle a lot of the powder that we use in our manufacturing. There are other aspects when it comes to EHS that you need to be careful of. These powders, you need to actually watch out quite carefully, but it's mainly very contained, so you can actually do that in a very safe and secure environment for the workers. But even that, looking forward, I think that's quite, there's still room for improvement, but I think from an overall sustainability aspect, it's a great technology. And other parts, I just have this piece here. It's actually also a real product for one of our columns that we have. And what I found intriguing was, we can do these pieces, but actually they printed the packaging with it.
Oh.
So this is the packaging that we use in order to, because otherwise you lose those little pieces in the printer. And then those things, I mean, it's just amazing for me what you can do that you couldn't do before.
Mm. And so we've had some new terminology thrown around, like additive manufacturing and the 3D printing. Is there actually a difference between those two?
Well, you have to, I mean, we've talked about additive manufacturing and subtractive manufacturing. You have to imagine a cube. In case of the subtractive technology, you have to grind away the parts and the material that you don't need in the final part. In additive manufacturing, you basically use a digital model and just print whatever you need in that specific part. Anything that's not being used in case of powder, it's being reused, or in case of filament, you can just use just the parts that just the quantity of filament that is required in the part. So basically, 3D printing is additive manufacturing, just because you can do so much more than you can do with subtractive technologies. With subtractive manufacturing, you need a highly expensive CNC machines, for example, 7-axis, 8-axis, which even if they are so expensive, you cannot do components which can be easily done with a cheap 2D printer. So for overhangs like the parts that Dirk showed here can be done easily with a 3D printer, and highly complex parts which cannot be done by a CNC using subtractive technologies are easily done with additive manufacturing, which is 2D printing.
And the core of this is some digital models. Yeah.
In both
So
cases.
this is, yeah. So that's really interesting. And automized 3D printing.
I just wanted to add something to the last discussion, because for me, additive is the overarching, and then 3D printing is one piece of additive manufacturing. Because if you think about the printing process, that's one way to do it, but there are other ways to do that. And if you think about bioprinting that you mentioned, where you actually just basically manufacture a print as a structure where you embed cells and the cells grow, and in a sense that's also additive manufacturing, but then it goes way beyond just the printing itself. So I think additive is a wider field, and it's less limiting. When you think about the printing process, it's just one way of doing additive, I think. I don't know, Stefan.
Yeah, I agree.
So Stefan, you had some examples, and you're talking a bit about how the efficiency had improved dramatically. Could you tell us a bit more about what's the business case here?
The business case from our point of view, we are a metal cutting company in a big part of it. But the thing is that a lot of parts has to be finished in some way, because the resolution of that 3D printing today is sometimes not good enough. You have to talk about microns, and then you have to do some grinding or some metal cutting or whatever. So it's still a big business. But also, as another part from our point of view, is we are having 75 years of experience in metal powder manufacturing, and that is very important to know that the quality of the powder has to be really good to actually get the parts that you are looking at here.
Yes.
So the technology behind it is really high skill, and a lot of engineering hours into that.
Yeah, it's not just a threat. I mean, there's a huge opportunity.
It's very
high tech, absolutely needed for the powders and for the software that's needed, but then it allows you to basically manufacture things that you otherwise couldn't manufacture. I mean, this is one that's printed as one piece basically, with just a spacer in between, but it's actually contained of thousands of different pieces. So I mean, you have totally new design possibilities that were not possible before. So that's why it does create a huge space for creative people to think about out of the box and think differently.
Definitely think outside the box.
Like, for example, Calin here with an example. Do you want to tell us a little bit about, because you were very clear on how your business is impacting health and the future. But is there a business case there?
Yes, I mean, think about this. Being able to 3D print parts, any kind of parts, not just like, which is my dream, by the way, just emailing me a car part which broke in my car and just had to replace it. with any kind of human parts, for example, in the future. Right now we are being funded by European Union to build two important components of the human body, or let's call them components, even though it's just a simple organoid tests. The pancreatic islets, which are the part of the pancreas which is secreting insulin, and the second project is printing a non-functional prosthetics for women suffering of cancer, uterus cancer, which had the uterus resected, and they have a huge hole in there. So we need to fill that with a 3D printed prosthetics, which is non-functioning, but it's healing the wound much faster. So yeah, I was telling you about the fact that there's a huge opportunity here, and I envision that in the future we'll be able to 3D print much more than just simple components like we are doing right now. Obviously these are much more complex, but nevertheless the future is intense.
And it's here today. I mean, I had two opportunities. One was with Professor Shaw in I think Pittsburgh, and she printed actually a structure that can use as an ovary for. So they used it for mice. So basically, they printed a structure as a biologically active organ, if you want to, where they could explant eggs from a mouse. Actually, take them out, radiate the mouse, and then put the eggs back in, and the mice could generate children, I mean little mice, and not just the first generation but also the second generation, so they didn't have any genetic damage. Imagine that kind of technology for women with cancer who have to have radiation therapy, and you can actually rescue the eggs and then implant them back in. I mean, I think it's just amazing what's going to be possible. Obviously she's on the track towards medical application in humans, but just the possibilities are mind-boggling and go way beyond some of the obvious applications that we think about. It's really fascinating.
And you have to imagine that, again, we are not a largely funded company. We have foreign partnerships, for example, with LTHD corporation, just to be able to ease up on the cash flow issues, because we're talking about the business. But this is a 3-year-old company who's actually building, well, hopefully in the future, transplantable organs. And we've developed the technology for keeping alive the stem cells for as much as possible, and providing them the chemical environment and the chemical composition for them to thrive and form that specific organ. So there's a lot of directions where we can go in this situation.
So what other kind of applications could you expect, or could we expect in the coming 5 to 10 years? Is there anything that you would like to add?
I can show another piece that we have here. I mean, GE does a lot of imaging equipment, so X-ray and PET and CT, and obviously we can then create 3D models that we can print out. And then in this case, there's some piece of the skull missing, so you can actually think about parts that need to be replaced here, and you can model them and you can put them in. That's one application. But the other thing is, like, if this was from a patient and the doctor needs to perform surgery, let's say there's a tumor somewhere sitting here, so the doctor can actually see a 3D model before the surgery, can think about, like, okay, how do I get in? What do I need to do? What are maybe important parts of the structure of the brain that I need to avoid? Those things are applications that are being used today, and I think you can just extrapolate what might happen in the future, where you can use that even more, like replacement parts, but also planning, and if you're developing the right type of software that can help us actually simulate upfront what might happen for a 3D printed part, I mean, there's so much opportunity.
I have a real life example, for exactly the same thing that you described here. We went on a fair in Bucharest a couple of years ago, and at some point there's this really stressed out guy came to me and gave me a really small heart. And she said, I've just come out of the surgery, and I wanted to come here and meet you because I wanted to show you this model. This is a real anatomical correct model of a 6-year-old's heart, a young girl. And I was able to 3D print this 6-year-old's heart, which is basically her scan, her heart, and be able to practice how would I enter with the knife in order for me not to damage, because the heart area is a very highly vascularized area, and if you cut more in a specific part, then you can create much more problems, a lot of problems. So he said that he was able to practice on that anatomically correct heart, and he was able to shave off 30 minutes of her whole surgery, which means that 30 minutes less for anesthesia is 70% less chances of developing brain issues just because you were able to cut the surgery time 30 minutes less. So yes, I mean, right now this is an actual technology which you can use, but in the future, imagine what we can do. They've emailed the first wrench in space. They've actually emailed it on an International Space Station a couple of years ago, and the scientists and astronauts, they were able to 3D print it in plastic, and they were able to actually use it. So
yeah, that's really, really interesting. So we have GE Healthcare, Sandvik, and Sim3D here. Well, you're working with healthcare and pharma and biotech, metals, and 3D printing of biomass. How could you actually think about, could you work together in some way?
of course, I mean,
You might need some metal powder for that.
You make the metal powder for that one, and the machines maybe, and you make software that we can simulate, and the machines itself, and we all might be interested in working with someone who provides the biological materials to print. I mean, I think there's a lot of opportunity, and I think that's why, I mean, a company like, a conference like UPPSTART is important to bring us together to come up with ideas how to work together. Yeah. Also with startups, right? Yeah.
I kind of feel left out now, energy, but maybe we could actually be providing the power so that you can do these great things.
Even though
I like the question that you have about how can we feel it in the daily business, but I think a lot of parts that I don't think that the regular people will actually notice that it's a 3D printed part, because it's things that you will not notice. It will be bent holes and cooling channels and whatever that is not possible to do. You have to do it with additive. Yeah, it's something that this is a part. How did they manufacture that? Yeah, that's additive manufacturing. So a lot of parts that you cannot tell that if it's 3D printed or not.
Actually, to add to that, we had, of course, there are lots of our customers will never accept that, right? And we had that kind of attitude in some of the senior management and when we started out. So we basically, I think it was for these parts, actually we made the first prototypes, we sent it to our customers, not telling them that we just said, like, look, we have some prototypes, can you test it? Yeah. And they tested and said, it's great. And then we told them, well, you know what, we actually manufactured that with 3D printing. And they said, well, we don't care. We don't care as long as, we have our specifications. It needs to be stable, it can't leak. In our case, it can't extractables, leachables. In biopharmaceutical production, very important. So they have their tests, and they said, well, we tested it, it's fine, we can use it. And then they don't really care how we manufacture it, as long as it fulfills their needs. So, and I think that took a lot, like, kind of learning for some of our guys who said, like, oh, customer will never accept it. When
that's a really great insight. Do you agree, Stefan?
Yeah.
And you as well? Yeah. In the end, if you're saving lives, it doesn't matter how it was grown.
Yeah, I mean, obviously, if I'm saving your problem, then you don't really care where it came from. Obviously, it should be ethical, but nevertheless. Just circling back about the collaboration, just like in any companies, the team is important. For example, we have a highly pluridisciplinary team. It's important to form strategic partnerships as well. We are not building these machines alone. We have a consortium of highly technical universities and medical universities, because there's no possible way that we can cover all of the medical aspects, for example. And this is what I always say, we are just engineers, we're not doctors, and we need the skills of other companies, larger companies, universities, to actually guide us and tell us exactly what we need. So in these two projects, for example, we are working with the University of Heidelberg and two other companies from Germany. And the other project for the prosthetics, we're actually working with Research Institute of Sweden. So we actually have financing and brain coming from Sweden, telling us, okay, we need these kind of processes, engineering processes, in order for us to achieve this. So yeah, working together actually is for the mutual benefits for everyone.
That's fantastic. I'm so happy to have a format where you're all actually meeting and discussing the future. So the next question and the last question for me is actually related to a lot of what we've already talked about, but why should we be doing this in Sweden? Why in the Nordics?
I can give you one answer. I mean, we're a very international company. So we have actually, for healthcare, our center of gravity is really Chicago area, and that's where we have the headquarters. For life sciences, it's more Europe-based. But we put the European Center for Additive Manufacturing from the research perspective or from the R&D perspective here in Uppsala, and it worked out great. And now the next step is actually moving into manufacturing, and so one of the logical situations might be in Sweden, so we're actually very heavily investing into that. But Sweden has an innovation-friendly environment and has the skills and the people that know how to do it, and so the know-how is there. And for example, for some of the locations where we try to do it also internationally, we can get this type of skills. So there are certain things that are very important where Sweden has a good competitive edge, I would say.
Totally agree with you. Why say it again?
Yes, exactly.
I mean, leaving politics aside, the environment that Sweden is providing. Again, I'm just an outsider, and I'm from Romania. But what I've seen here, because I've been here a couple of times, and in Norway as well, the politics are actually encouraging research and development are being encouraged heavily and are being supported heavily. And there are a couple of hotspots all over the country, all over Sweden, where they can actually develop and come up with ideas where nobody in the world are able to do so.
And I mean, just kind of, it leads us a little bit away from the additive manufacturing, but we just built up the Testa Center with Swedish government supporting us doing it. And that's fantastic. It's an environment right next to our factory where startups can come to do certain things that they otherwise standalone couldn't do. But I mean, that's been possible because the government was very interested in working with us in government, so that's a great example. So definitely a friendly environment for that.
Wonderful.
I mean, can Sweden improve? I think so too. Maybe maybe making it a little easier, a little faster. I mean, there are definitely things that Sweden can do where the US has some advantages. They're very fast moving and so on. So it's not that Sweden is just great, but there are other areas where Sweden can also improve. But I think in a competitive state, I think it's a great country to do innovation.
Great, thank you. So now I open up the stage if you have any questions from the audience. Yes?
Yeah, thanks. Very interesting. Do you think the way people source prototypes and components will disrupt the industry? Because obviously if you've got 3D printing, you don't need to subcontract to someone else to do a prototype for you. So does it allow you to reduce transport costs and logistics and time? Will that change industry where you might do more, for example, in Europe on site compared to how you used to work and get suppliers? Will that change, you think?
Absolutely, yes, I would say.
Yeah, totally. You can go into Clas Ohlson and buy a 3D printer for plastic parts. So, of course, it's come more to the common people to get a 3D printer today. So I think it will be some movements in the business, definitely.
I talked to a company that does, a German parcel system. So basically, the people that transport things. And they believe that additive manufacturing is actually disruptive to their business. Because where you need to transport parts today from many different places to assemble it, well, you print, first of all, the whole thing, so you don't print the individual pieces. So you remove the manufacturing piece, but you also remove the transportation piece. So I think it has a big potential to disrupt. Are we there today? I think a lot of pieces still need post-processing, you mentioned that. So it's not just the printing, you need to do something with the parts afterwards, so it's not quite that easy. So it's not happening right away, but I think it's definitely very disruptive, or has disruptive potential to do all of these things that you said. Spare parts is another one. I mean, we produce spare parts, and our instruments live for 10 to 30 years. So basically, we need to produce them, put them on stock for many, many years. Now, what if we could just print them out whenever we need them? inventory costs. I mean, it's a lot of potential to save money.
Wonderful.
Yeah, there's one disadvantage with 3D printing today is the speed of it. It takes time to build it, to build a part. So that's the one. So if you want to manufacture 10,000 parts, then you have a big problem because you have to have a huge amount of 3D printers. But it depends on the volume of the part that you have to print. If it's small, no problem. But it's big, then you have to have a big scale of 3D printers. So difference of what's the true business behind it. How can I get down to the best cost per piece? So you have to think, should I do 3D printing or should I do convenient old way with metal cutting? So
There's still
some parts you have to have that in mind.
Absolutely.
But I think with 3D printing, the evolution of it, it's going faster and faster, and the resolution of it getting better and better. So you have better benefits sort of in a business way.
And that's shifting. I mean, that's really where we were a year ago, where we are today, where we're going to be in a year, is shifting. I mean, but the volume is absolutely critical. But then also, as raw materials get cheaper, we get things more under control. I think automation is a big topic in that space as well, where you just don't think just about the printing part as well. Like, how do you get the powder into the machine? Like, how do you get maybe parts that you need to print around into the machine, get the parts out, post-processing. There's still room for a lot of innovation, I would say.
Yeah, totally.
That's amazing. So I would really like to thank you for staying on top of things and for driving technology forward in your respective areas, making life more developed for us without us even knowing, perhaps sometimes. So I'd really like to thank you, and with that, give you a big round of applause. So after this, we have invited some people to an exclusive mingle outside with some champagne for the industry stage. So if you've been invited, I would love to see you there. And after that, we have at 6 o'clock the after party starting at Elite Hotel. So I'd love to see a lot of you there as well, because this is really an interesting place where you have people from all over the world, and Sweden and the Nordics coming together from different industries, startups, investors, students, and everyone coming together, and it's really an area where there's lots of potential. So I'm really looking forward to the rest of the night, and also to have a very fun night with you later. So thank you, everyone, and thank you for being such a great audience.